Welcome to the sixth video of this training program. Now, in this video, we are going to focus on what Pandas library basically is, how to use it, and how to perform basic statistics and some exploratory data analysis of any data. We are going to look at forming a series, a data frame, as in the Pandas library. So, what is Pandas? It's basically an open source library built on the Numpy library. It allows kind of a faster analysis and data cleaning purpose. So, data cleaning is basically a method to clean the data, to clean the unnecessary data inside your data set. And it needs a lot of processing, a lot of factors to be considered, which we will be discussing in the next video itself. But right now we are going to focus on how to basically do it. It excels in performance and productivity. So performance wise, Pandas is one of the best tools for data analysis. It has built-in visualization features, so you can basically visualize your data in form of really good visualizations which give you kind of insight about how or why the data is as we expect. It can work with data from a wide variety of sources, so the data can be imported inside the or using the Pandas library from an Excel file, a CSV file, or even a SQL database. So one of the first and the most important data structures used in Pandas is a series. A series is basically one-dimensional labeled array capable of holding data of any type. Now over here, focus on the word labeled array. A label is basically a feature you use in a data set. A feature is usually used to predict a value in machine learning and data science field. So for example, I have an apple and I have to predict if it's sweet or not. For that, there are several properties which we can base upon. It can be about the redness, that is the color gradient of that apple. The second factor can be the size of the apple. So these two factors, or say two features, are to be considered to predict if an apple is sweet or not. So these two features are called as labels in data science, and the labels are kind of put a lot of effort in predicting new values or values we actually expect. Now these labels, these label data have to go through a lot of processing through a model, through a machine learning model, to predict the right output. So to be capable to predict using a machine learning model, the data should be cleaned, properly analyzed, so that there is no biasing or no such kind of problem that it would make the predictions wrong. Now we can create a series. First of all, let's import numpy as np. Now this is not needed, but let's see. Then there's pandas as pd. As we have seen in the previous video, we can use the alias as np for numpy. Similarly, we use pd for pandas in standard way. Let's import it. And now, until it gets important, let's create a series by using these two lists. So I want to create a series wherein my index is the list represented here, that is A, B, C, D and E, and the values list is kind of the corresponding values for each index. So A will be assigned 23, B will be assigned 4, C will be assigned 5, etc. To create it, we just use pd.series method. As we have imported pandas as pd, we use pd dot series method. Basically helps you to return or create a pandas series. Don't forget to use a capital S while creating a series. Don't write this way. Then inside the parameters are basically the data and index. So the data here is a value and index is as a list of indexes. You might find some familiarity between a series and a dictionary now. It's kind of mapping an index to a certain value. And you can see this is the series we have created. A is associated with 23 and so on. So basically these are indexes and these are the values for certain label. Now I haven't specified that label since I don't know what the data is all about. Now we can also create a series by passing in a dictionary. Let's create a dictionary D and just pass in the dictionary directly. You don't have to specify the values and indexes, since as in the dictionary the keys are considered as indexes and values are as values, and can create that way. Then we can also create a series by using Numpy arrays. Let's see, here I have created a B, a Numpy array B with these values. Then I'm creating a series of this Numpy array. Now you can see I didn't have to pass in the indexes because the pandas series automatically by default creates a list of index or creates the indexes for your values if you haven't specified. Now let's create some series and add up together. Now my first series has 1 2 3 4 and these are the indexes, these are the indexes, these are the values. Remember, first parameter has to be the values and the second parameter the indexes. Now that I have created these two series, let's add them, and you can see after adding, the common indexes have gotten their values as certain value. There's this 4, there's 8, etc. So basically adding, but the uncommon values or the unique values have got the n value, that is not a number. Okay, just so as you know, as you add to series, basically the common elements values are added up and not the unique elements. Now this is just a basic overview of what a series is. Don't have to deal a lot with it, even if there are certain lot of operations available with a series. As of now we need to know this much, and let's move forward towards a data frame. So as you know, a series is one-dimensional labeled array capable of holding data, so one label. Similarly, a data frame has multiple labels. It can have even one label, and it can have multiple labels, so as to create kind of a matrix having the rows as indexes and columns as labels. Now, as I told before about an example of predicting the sweetness of an apple based on its characteristics, like its color or its shape or its size. Now we can see we need three or more, or basically say multiple qualities, multiple characteristics, multiple features to predict if it's sweet or not. Now that's when a data frame is useful, when you have to deal with multiple labels and predict a value on the basis of those multiple labels. Now I'm creating a data frame, a random data frame over here. It's not going to be meaningful, but let's just see what we can do with a data frame. Now I'm just importing some random library which is called random to get some random values for my data frame. I can't feed in a particular data frame right now, because all I want to do right now is to demonstrate how it's done simply, rather than going for a real data set right now. We'll be doing that in the next video very neatly. Now I'm just setting some random values over here, so you don't need to know what all I have done with the random library. You can know that, you can just search for it. So here I'm just creating a data frame with some random values having labels as W, X, Y, and Z, and my indexes as A, B, C, D, and E. Okay, and let's see how our data frame looks. So you can see W, X, Y, Z. These are the features or labels I'm talking about, and A, B, C, D, E are the indexes, and these values are kind of random I've taken, and in a real life data set there are really different sort of values, and there's a lot of fluctuation you have to do analysis on. Now we can sort values by using this dot sort values method on certain column of the data frame. So here I'll be sorting W, and let's see, you can see the minimum value is minus 2.018 and max is 2.7. so it's sorted. It kind of returns the sorted sorted list of elements. Okay, sorted series actually. What if we actually try to check the type? It should return series. Okay, so whenever you consider one column of a data frame, it is a series, because you know it is 1D. Okay, now to actually assign these sorted values to the column, I have to use this thing. Okay, I have to assign it, because this is just returning me the series, and I'm not assigning it to this real life or real data frame. Okay, to actually assign it, you have to use the equal operator and assign it. We are not doing this right now, but just to know. And we can also access multiple columns of a data frame by just specifying a list of the column names. So remember, use square brackets, and inside that use another pair of square brackets and specify your column names, and you can obtain those W and this Z. And to create a new column of data frames on the basis of the existing columns, you can directly specify your name of that column, or say indexing in technical terms, and assign it certain value. Now here I'm going to assign w plus z value as my new column for the data frame. So let's see, I've assigned it, and you can see a new column is added, new, with the values which are basically addition of w and z columns. Now you can also drop a certain column from the data frame by using dot drop method. Here you have to specify your column's name and also specify your axis. Now here I can even say a and axis equal to 0, but always remember to specify axis when you have to drop a column, because the default value of axis, if you just don't give any axis value to this function, it will be 0. Now if I drop new column just created, you can see it's dropped from the data frame. You can also view the shape of the data frame by using the dot shape method, just like the Numpy arrays, right? Now to grab a certain row, so if I have to take row A, just specify dot loc or dot location dot loc and specify your index, and you can get your row as follows. Okay, just remember to always use dot loc or dot iloc. We'll be seeing that when you have to access the rows. While to access columns, you can basically directly write down this way, but in technical terms, or the right way to access even the columns or rows is by using the dot loc or dot iloc method, because in whenever you have to create some projects, there is a possibility that this will return certain wrong values, and I'm not going to explain why that contradiction actually occurs or when that occurs right now, but just to know, always make a habit of using dot loc or dot iloc method. So dot iloc method is basically specifying your index. So here I'm specifying index 2, that is 0 1 2, that is C. The row having C index will be accessed, you can see. Yeah, then to get a particular element, so if I have to access this element minus 0.848077, I have to specify both indexes, that is row and column. Just use the dot loc method as I've mentioned before, and use this to access that value. Always see for the syntax. Syntax is always important, that's why. Now to get a subset of two elements, we can also use dot loc and just specify two different lists to access two different elements. So you can see a w a y. So these are the rows you want to access the elements for, and these are the columns you want to access your elements for, and you can get those 4 elements. Now you can also use conditions for this data frame, condition on the basis of values, by just specifying the logical operators. Now what if I have to look out for the values in the data frame which are greater than 0? Let's see. First, it returns a boolean set, a boolean matrix, or a boolean data frame having the values true or false for if the data frame's elements values are greater than 0. And you can also access the data frame itself by value by just specifying the condition inside as a index for the data frame, and you can access here. If there's false value, there would be an n, that is not a number value. Okay, so you can you use these conditions easily for anything. Okay, so if I have to see just for the w column greater than 0, and again access the same, just specify your condition inside the square brackets and access your data frame by writing your data frame's name, and you can see this thing. Now many may have thought of, if I've gone fast, again to create a data frame, here is data frame method. To create a series, there was series method. Always remember there is first letter of each word as capital. Okay, no, because this is really important and this is the first step, right? So remember that. Now that we have seen how we can access based on the conditions, we can again access indexes, or say the particular columns inside those that conditional data frame. So I have accessed this data frame. You can see this data frame. What if I have to access just y and z columns? Just specify the y and z columns ahead, as I have specified, I have shown above here, or where is it, here, right? To access certain columns, just specify them ahead and you can access those as well. And then you can also use multiple conditions inside a data frame. So this is my condition for w greater than 0 and df of y greater than 0, and I'm printing the data frame. So here are only these two rows having the values of w and y greater than 0, right? You can even write here or, and you get if any of the values of w and y column is greater than 0, print it, and we get the data frame. You can also reset the index to default indexes by using .resetIndex method, and you get a data frame having the indexes as 0, 1, 2, 3, 4, etc. And the column, an additional column gets created as with the name index, having the previous indexes. Now we can also set other indexes for our existing data frame. To do that, just create a list of your values for which we are going to assign it as an index. So I'm creating one new column, df stats is equal to this new list. Let's see data frame. We can see there's one new column stats, and can set this as an index by using setIndex method and specifying our column, and you can see the data frame has indexes as stats. Now we are going to look at basic statistics of this data frame. I hope you have understood right now what we have performed, what we have done basically with the pandas data frame, what a series is, what a data frame is. Okay, now I've already shared some links with you to go through some basics of statistics such as mean, median, there was IQR, quartiles, there was measures of dispersion. Now to find some basic statistics of the data, pandas provides some inbuilt functions. Now to find the mean of my data frame, let's say data frames X column, just write dot min, write your series, or say the column you want to find your mean for, and you get the mean for X column. Similarly, you can also find median in this way. Okay, so it makes it easier to get your mean and median without actually writing some hefty functions for that. You can also find interquartile range by creating q1 q3. Now there's also another function in pandas, that is dot quantile. So again, take your series on, then use dot quantile method. Here you can write 4 values: 0, 0.25, 0.5, 0.75 and 1. So basically what 0.25 means is q1, 0.5 means q2, 0.75 means q3. I hope you know what q1, q2, q3 is. Okay, I'm not going to explain that. And we are creating q1 and q3, and we can find directly IQR by subtracting q3 minus q1, and you can print, you can see this the IQR of 1.059. Now to plot this, or to find outliers, so what are outliers? Many have asked me this question for the previous assignment I had assigned to you. So outlier basically means a value which goes beyond a limit. For any data set or any column having data, the values, there is always a certain value, not always actually, there may be a certain value which goes out of the limit, out of the bounds of for the data. So it kind of affects when training. So you wouldn't understand why we do this, why we remove outliers or process outliers, because you don't know what a machine learning model is or how it gets affected. But for now, know that when you find an outlier in your data set, it kind of affects the training of a machine learning model. The accuracy or the prediction made by a machine learning model gets pretty wrong sometimes, just because of many outliers present in the data. Now it's not always compulsory to remove outliers as soon as you discover them. This is based on what kind of data you are processing, what kind of qualities or what kind of features you are processing about the data. Sometimes you have to include some outliers in effect to get your right model trained. Now I won't be discussing more about why or how to actually remove the outliers just for the machine learning model, but for now I can say is that you how to find a outlier. So as we have seen, we have found IQR. Now let's try to do a box plot. What a box plot does is basically it plots the limits for a variable, a feature, a label, which show the limits of that feature, above which and below which a value would be considered as an outlier. And you can see, you can just directly use .boxplot method. This is actually a visualization library in Python, that is matplotlib. .pyplot is actually a kind of a class, you can say, or sub library inside the matplotlib, and I've imported it as plt. Now actually I don't need this, but right now actually I'm using pandas library for plotting. Okay, I'll be covering this as well in the next video. For now, just see how the box plot looks. You can see there are limits above which and below which a value would be considered as an outlier. In fact, here is a round figure which is outlier already. For W, these are certain values which are found to be outliers in the data. Even in Z you can see, while in X and Y there are no outliers you can look at. Okay, now to find the maximum and minimum limit, kind of, you just have to use the quantile values we have found, that is Q1. You have to subtract 1.5 into IQR from it, and you get this as a minimum value, that is, you can say this value. And again, you can find the highest value above which a value can be considered as an outlier by using Q3 plus 1.5 into IQR. Just kind of remember these formulae. We always use this in exploratory data analysis. Now in the next video we are going to cover the exploratory data analysis, how a data analyst tries to analyze a data. Okay, so always remember, most of the times the outliers need to be removed, but for a data which is very huge and has various values, we have to consider all the values. There may be some extreme values. Let's say over here I have this data, W column. Okay, you can see there's 2.7, 0.65 and etc. What if I have a data of say around 10,000 rows having say 100 values of values above 2 or 3? In that case, even if the data may be considered as outlier, the number of count or the count of the data above that certain threshold value is high. So in those specific cases we have to consider some outliers. There are actually rules behind it and we can't actually go in depth with it, but for now just know, basically whenever you have a very huge data and you have to remove your outliers, always try to look out for the count of the data above certain threshold value that you are seeing as outliers. If there is a high count of the data, you may want to reconsider if you have to remove that outlier or not. I'll show a basic example in the next video for sure. Now we can also find correlation between different features, different labels, by using dot correlation or dot CORR function method, and you can get a data frame or a table having correlation values. So W to W is one correlation value, W to X is minus 0.076 correlation, so it is really less. And on the basis of this, we often try to solve regression for problems. Now I'm not going to explain what a regression problem is, but know that to predict a certain value on the basis of there's X and there's Y. So on the basis of X, if you are to predict Y, you have to find a certain correlation between X and Y labels. So if I say here, you can say there is a high correlation between Y and X. There is 0.983 correlation value, which is really high. That's why you may consider these two as for your predictions or whatever. Now there is also a lot of rules down there on how to select or what to select, which will be explained further if you have actually registered for the machine learning program by Harshmeet Singh. Now ahead, there's also df.describe method, which actually describes you everything from the count of the data, mean, standard deviation, minimum. There's quantiles. quantile values, there's maximum value. So these all statistics are displayed by dot describe method in pandas, which is really easy. Then you can also check for if your values have nn values by using dot is na method, and you can see it returns matrix kind of data frame actually, which has the boolean values if it is nn or not. For now we can see our data frame is completely clean, that is, it doesn't have any nn value, and you can also find the counts of non-nn values. So all 5 values I have are not nn values, they are some values, right? So for now, just go through this video. I'll be sharing this Python notebook with you, and this is going to be a bit heavy on you as we have moved a bit faster, but on the basis of this we'll be performing the data analysis of certain practical example in the next section. Thank you.